So, hello everyone. Well, welcome to what I hope is going to be the beginning of a new series of philosophy discussions. This is our first effort. So consider this an experimental philosophy. And I don't mean experimental philosophy. I mean a discussion about philosophy that is experimental. Um, and we're going to particularly be trying to connect things we've been working on recently, I've been working on recently from our physics project and other places with kind of traditional strands of thinking in philosophy. I would say this is a new effort that's part of our Wolfram Institute initiative, and we have a sort of fledgling philosophy effort there, and this is a part of that. I would say from my point of view, I think I don't know enough about philosophy, so I'm trying to learn more about philosophy. There are things that I would like to, in a perfect world, we would find out that some question that I've long been wondering about, thinking, is there something obvious one could say about this or that it will turn out that some philosopher from the 1700s already said that, and I can immediately pick that up and use it for something about physics. So that's my theory. So for our first such discussion, we have Mark Jago, who is a
Hi.
philosophy professor and philosophy podcaster and generally philosopher. Um, and um, I thought maybe we would start with I know, Mark, I think that you've worked on things about kind of in the absence of perfect knowledge, how do you make models of the world and so on? Maybe that's an incorrect characterization. So one of the things that to me has been very important in understanding sort of where the laws of physics come from is the idea that the laws of physics are the way they are because we are observers of the kind we are. And that, the reason we believe that we can talk about fluid mechanics is because we are observers who don't trace every molecule and so on. And I guess I'm curious what the kind of, whether you can say something about sort of the historical arc of thinking about kind of how we perceive the world relative to what we are like as observers of the world.
Wow. Yeah, that's a really huge question, which kind of sits in that boundary between metaphysics, traditional metaphysics, and epistemology. The traditional boundaries have it that metaphysics attempts to describe the world as it is, perhaps irrespective of us, and epistemology is looking at how we come to know about the world, whether we can know about the world, what's rational to believe about the world. But there's an interesting interplay between them because some metaphysical theories very much conceptualize reality. Their analysis of the concept of reality is very us involving. There is no deep gap between reality and our knowledge or our ability to conceptualize it. So on these kind of views, we shouldn't think of reality and our knowledge of it as wholly separate things. The world is in some sense shaped by our abilities to make sense of it. And I think that's kind of the ballpark that
Yeah,
your picture might be in.
yeah, yeah,
Given
right.
the kind of creatures that we are, that dictates or shapes what the laws of physics could look like.
Right. I mean, at the very simple level, if we could trace every molecule, we wouldn't be talking about flows of fluids. We'd be talking about this is what the molecules do. If we thought a million times faster than we do, we wouldn't necessarily have the notion of space. We would just say, oh, the photons are arriving in this and that way. The fact that there is a state of space at this moment in time wouldn't be something that would particularly occur to us. And I guess I'm curious in this idea of the world as we perceive it. And people often seem to say sort of the laws of physics are the grounding of the world as it is. But I think what has emerged from what I've been working on is that the laws of physics for an observer like us are the way that they are, but there is a deeper version of what sort of, the possible worlds are, most of which we don't sample. And I guess
Yeah,
maybe
there's a
go ahead.
reality kind of underlying the level at which we can interpret the laws or extract the laws, and the limit is really on us and the kind of creatures that we are. But there is something out there, sort of that gives rise to all of that. Is that the kind of picture? It's
Yeah,
just
yeah.
that it's too fine grained. There's too much information or something like that for us to kind of carry all that information in one go. Or
Right. I
yeah,
mean, and the way that we sort of perceive the what the world ultimately is, in our picture, it's this thing that we call the Rulliad, which is this sort of entangled limit of all possible computations. The Rulliad is very, very big. It has everything that is sort of computationally possible in it, which means, among other things, it's a unique thing. It's not something where we get to say somebody picked our Rulliad and not another Rulliad. It's the everything thing, which I know is a concept that's come up in philosophy and theology over and
it
over
really
again,
has. Yeah,
the
yeah,
everything
yeah,
thing.
yeah.
Um, and I'm curious about this thing. We've got the everything thing, and then the question is, how do we perceive the everything thing? And the thing that has been, the surprise in terms of the technicality of it is that we can say, given certain constraints on us, like that we're computationally bounded, like that we believe we're persistent in time, those constraints alone are sufficient to tell us that the sampling we take of the everything thing corresponds to certain aspects of the laws of physics. And so I'm sort of curious what the antecedents and sort of related thinking have been in kind of the history of philosophy and so on.
Well, I guess one big question in the history of philosophy, particularly in metaphysics, is the question of why is there anything at all? Why is there something, and
Hmm.
why is it that way rather than some other way?
Right.
And one answer, one plausible answer to that, to why is it this way rather than some other way, is that, well, when you actually get down to the ground floor of reality, when you really get to analyze what reality is rather than just how it appears, it encompasses every way things could be. So there is, as it were, no other question of it being some other way. It incorporates, as you say, everything, not just everything that happens to be, but everything that could be. So
Hmm.
reality is all encompassing, all the actual and all the possible ways things are. So, as it were, there's no further question of, well, why is it like this rather than some other
Well,
way.
I mean, my
But
impression from
there
the
is a
history of
question of
philosophy.
why it appears the way it is. That's a further question.
Right, but I mean, my impression is people like Leibniz were talking about, all possible worlds. And his selection criterion was, maybe this is only Voltaire's characterization of it, we live in the best of all possible worlds. That was his way of selecting which of the set of all possible worlds was the one that we actualized, so to speak, or that's actualized for us. To me, that's an unsatisfactory and naive, but very theologically oriented
Sure.
approach. I
Yeah.
mean, my
Yeah.
approach is much more, self-centered of an approach, talking about the way that we are as observers rather than the way God places, makes the universe be, so to speak. So I
Yeah.
guess yeah.
Yeah. And that's it, sort of Leibniz gave us the idea of possible worlds, multiple possible worlds, and a very unsatisfactory explanation of why we're in the one we're in. But once the idea's out there, it sort of takes on a life of its own. And possible worlds have kind of taken on a life of their own to the point where one sort of contemporary view is that reality really comprises all of the different possibilities. And there's a question whether they're all kind of entangled or whether they're in some sense separated, but I think that's a further issue. And then the issue of why we are in, the reality where we're talking rather than the reality in which we're each doing something completely different is really just like the question of why is it now rather than yesterday, because that's where we are. That this is just where we happen to find ourselves. So it's a matter of self-locating. This is real for us because that's where we are. But if we were in
Yeah.
some other location, something else would be counted
Right.
as
I
real
mean,
or actual.
that's the view that I tend to have. I mean, within the Ruliad, there are many places we could find ourselves. And for example, the fact that we believe in an objective reality, I suspect, is because our minds are all at certain points in the Ruliad, but our minds are clustered very close together. So we tend to agree about what's happening. If it was, it's the same as in physical space. If we were, in different times and places in the history of the universe and so on, we would not agree about certain aspects of objective reality because, one person would say it's really, there's everything is very stretched here because we're very close to the central black hole of a galaxy. And somebody else would say, no, 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 there's, inertial motion is a thing. So, my tendency, my guess is that the reason we believe definite things happen is because we're all really close together. I mean, this has been a mystery in quantum mechanics, for example. People are like, why, the idea that there could be many worlds and a whole sort of tree of possibilities in quantum mechanics. I mean, one technical thing that got missed there in the kind of many worlds view was people were thinking about the world as being a continuous place, where once you have a
Mm.
branch, the probability of a merge is infinitesimal. In the kind of setup that we have where everything is discrete, the possibility of a merge is just like the possibility of a branch. And so you have this kind of
Oh,
branching and merging picture that, and so then the question is, well, if we live in these different parts of branchial space, as we call it, why do we believe that definite things happen? Well, where in branchial space we may happen to be is just, as you're saying, it's like this matter of where, I don't know how one says it really, it's this coincidence of where we are, so to speak.
yeah,
But so,
yeah.
when there's randomness in quantum mechanics, it's because we happen to be at this place in branchial space. If we were at a different place in branchial space, the random numbers would come out differently, so to speak. But the fact that we believe that something definite has happened is because even though where we are is quite arbitrary, we're all pretty close together in branchial space. And so we tend to agree about what happened. And that's, I think that's, because that's one thing you have to explain is why is there objective reality? Why isn't it the case that all of our minds are perceiving quite different things? I mean, we don't know what each of our different minds is really perceiving, but it seems to be a reasonable operational extrapolation that, your mind is perceiving something somewhat similar to my mind.
Absolutely. I mean, we have a shared language and shared concepts, and the best explanation of how we seem to manage to meaningfully talk is that we are, triangulating on the very same portion of reality. It would be an amazing coincidence otherwise. And I
Right.
mean, I think there are explanations of there are similar kind of explanations of different but similar phenomena that why do we believe in the persistence of material, medium-sized material entities. I mean, once you kind of zoom in on any entity and really understand its scientific nature, it kind of seems to vanish, the boundaries of things seem to sort of confuse the issue. But if we were the kind of creatures that were not extended in space and time in the way we are, I mean, from one moment to the next, we find ourselves in roughly the same place. It's not like we're here now and somewhere completely different in the next instant. If we were, and I mean, maybe there could be minds like that associated with completely different physical locations from one notion to next, they probably wouldn't have the same notion of a physical object that we have. But given that we sort of move through physical reality in a fairly kind of stable way from one moment to the next, that's how we interpret the world. So we,
Yeah,
we kind of
no,
see it in terms of these, persisting medium-sized objects, kind of like us.
right. I agree. I mean, I think that the fact that we have this belief that we are persistent in time is what leads us to have any belief in stability in the world. I mean, in other words, but the fact that we believe we are persistent in time is at some level very bizarre because in our theory, and I think we're made of different atoms of space at every moment of time. Yet there is something where we manage to carry through that inner experience through successive moments of time. I mean, the analogy I often use is, if you're a fluid with a bunch of molecules bouncing around, there's an eddy in the fluid. The
Mm.
eddy is made of different molecules at every different moment of time. Yet there is a sense that we can identify there is an eddy thing that is something that is persistent. I mean, to me, for example, this persistence idea, for example, the idea of motion is not an obvious idea. I mean, I know I don't know the full history of the discussion of motion in antiquity, but the fact that you could have a thing and you move it and it's still the same thing is not trivial. In physics, for example, in traditional physics, if you're close enough to a space-time singularity, then in some sense, it really isn't the same thing. It's stretched, beyond all recognition. Yet, it's a thing we believe about the world, that there can be pure motion in the world. And I think that's directly connected to the fact that we have this belief in our own persistence, and that leads us to be able to talk about, the persistence of a thing and whether there is pure motion and so on. And it's
yeah.
So, but I'm curious, like for example, in the idea of motion, maybe we could talk about a little bit of I don't know the history of I mean, there were people like Zeno worrying about
right. There's the sort of classical problems of motion. The idea that if a thing changes its properties because it's moved, is it still the same thing, right? Because we know from Leibniz's law, if x and y are identical, they should have the same properties. So if x is here at one moment and it's there at a different moment, how can it be the same thing? So the standard response to that sort of thing is that time is this fundamental thing, and we relativize properties to time. That doesn't necessarily solve the problem of motion, but it does at least explain how something can be the same thing over time.
So wait a minute. So that's saying that you say relativized to time. I mean, okay, my view of time is that time is our perception of the computation that's going on in the universe. The passage of time is the doing of computation in the universe. And the fact that there is a universal sense of time is because of various kind of universal features of the way computation works. It could be the case that time as it runs in our brains is completely different from time as it runs in the universe and so on.
Sure.
But it isn't.
Yeah.
And
we might have an objective notion of time and a subjective how it seems to us time.
Right.
But for you, objective time is, as it were, the steps of computation.
Right, which is the same as what's happening in brains and minds and so on. And that's why there's an alignment of those things.
So in some sense, it doesn't make sense to ask how quick the computation happens, because time just is the next step.
Right. I mean, so, we don't know anything happened in the universe until we've been updated. So, and for example, if you say, why did the universe, why did the universe even get started? Well, this comes back to the thing you were raising before, which is why is there anything rather than something? Why is there something rather than nothing? How does that all work? I mean, the thing to realize about sort of the beginning of time and things like this is, in something like the Iliad, it's the notion of a beginning of time doesn't really make sense. It no more makes sense than to ask, 1 + 1 = 2. You could say, well, 1 + 1 is transformed to 2, and you can think about that transformation as a kind of a time step of 1 + 1 turns into 2. That's the kind of thing that's happening in time.
Oh, interesting. Yeah. I mean, yeah. I mean, people like Kant and the logician Brouwer made that kind of connection as well between, arithmetic, the natural number series, and time and computation, particularly in Brouwer, the logician, the founder of the intuitionistic constructive school of logic. This idea of our thoughts kind of going clunk, clunk, clunk along the series of the natural numbers, and that's where, as he applied it to mathematics, that for him that's where mathematics comes from, this kind of a sequence approach. But I think he thought of reality more generally as this kind of constructed medium in our minds by clunking along. Now, I guess you're not saying that we're constructing reality, but there is this sense of time, constructing from one moment to the next.
Well, in some sense, I am saying it's not that we are constructing reality. Reality is being constructed by the progress of computation. I mean, it's a little bit of a tricky thing because you can, once you have the definition of how these computations are supposed to work, then you could just say, well, let me just get the whole thing. Let me just run everything and just get this Rulliad and just have it sitting in front of me, so to speak. The issue is if we are computationally bounded observers, then our ability to explore that thing that's just plunked in front of us is still very limited. We can only explore one step at a time. So it's really kind of equivalent to say we are constructing it as it goes and observing it as it goes, so to speak, versus it's plunked in front of us and we only get to explore it sort of one step at a time. But I'm interested in, I know much less than I should about Brouwer. And, I've been, in my view of mathematics, there's this whole sort of notion of, you have these axioms, you construct theorems from the axioms. That's sort of a constructive view of mathematics. It's kind of also, in a sense, what Hilbert was going for. And you start from the axioms, and it's just a machine that constructs more theorems from those axioms.
Yeah.
I personally think that the notion of truth is a muddled notion that confuses a lot of things. Because this question of, it's like the old question of, this statement, you make a statement or you say this statement is true. What's the difference between those two things? And then this issue in mathematics of, what does it mean for something to be true versus is it a theorem that is constructible from the axioms I'm assuming? I mean, to me, it's a much more manageable, solid thing to say, is this theorem constructible from the axioms that I assume, rather than is this theorem true? Because then you immediately say, well, what does it mean for it to be false? What is negation and so on? I think it's kind of a mess.
Yeah. And a variant on that view is that we actually take this idea of constructing mathematical entities, mathematical theorems, we take the proofs of them and we say that's what it is for them to be true. So it's not like we have to throw out the notion of truth altogether. It's just that we revise what we mean by true to mean, in the mathematical sense, something like a proof or a construction or a verification or evidence or whatever. And that's a way of sort of rehabilitating the notion of truth to make it something more epistemically tractable, something that is doable by us or an ideal version of us or an ideal computer. And that's a very much an alive version of philosophy of mathematics in computer science, constructive mathematics. That's very much the way it's gone there.
So I'm curious about the notion of truth.
Okay, me too.
As a sort of societal matter and so on, it's, truth is a fine thing to aspire to. But the question is, when we try and define it precisely, we try and understand, what can we build on the notion of truth? So, for example, in my models of physics and metamathematics, neither of them really have to talk about the notion of truth. In physics, we're just talking about, what happens in the world. It's not to say it's true that this happens in the world. That would be redundant. It's just this is what happens in the world, so to speak.
Yeah.
Similarly, in mathematics, it's like kind of this is a theorem that follows from these axioms. I could say it is true that this theorem follows from these axioms. Now I could say this theorem doesn't follow from these axioms. Okay, so do I then say this theorem is false, or do I say the axioms are incomplete? I wasn't able to reach this theorem, and then people get very confused because they say, well, we could say it's false. I mean, to me, negation is an extra little thing that you put on top of.
Absolutely, and we get things that we can't prove either way. We're going to get in all kinds of pickles there because if it's false or we can't prove it, well, if you can't prove it either way, we've got a contradiction there, or it's these are tricky things. Historically, theories of truth, philosophical definitions of truth, try to say something substantive. Truth is ... and truth is a matter of coherence or a matter of correspondence or a matter of being most pragmatically useful. These are all attempts to kind of fill in the truth is ... And throughout the 20th century, kind of views tended more towards insubstantial characterizations of truth, whereby the word true, it's really just a way of summarizing certain things. So it's a linguistic device rather than a substantial philosophical concept. So, I could just sort of say, the last three things you said were true, as an abbreviation of saying, repeating the last three things you said, or everything in this book's true. It's just a way of, it's just a shortcut to reading out the entire book.
Well, but so then,
But I could always replace my use of is true by just saying the thing, very much like you were just saying.
Right, but I mean, so, truth obviously has also become almost sort of a political weapon, so to speak, of, is it true, is it not true, is it a fact, is it not a fact, those kinds of things. But I'm curious from from the point of view of well, there's a question of things. If you take, I'm curious, what does one need the notion of truth for? What is one going to build on top of the notion of truth as a, if one has this abstract notion, there are certain kinds of notions, like we can construct the thing. Okay, we can get some idea what we can build on top of that notion. I'm curious, what can you build on that notion of truth?
I think in contemporary metaphysics, let's say, the use of truth is very, very heavily downplayed.
I see.
The real question, or the more interesting question might be, do we have an objective fact out there or not in any particular case? And really, when we're talking about truth, really we're just abbreviating a discussion about, is there an objective fact about this, that, or the other?
Let's talk about what an objective fact is, though.
Yeah, I mean, that might be the more kind of, relevant notion.
But the concept that there could be objective facts, in some sense, assumes objective reality. And, in my view of things, there is ultimately an objective reality. It's the whole Ruliad. But the particular objective reality that we tend to agree on is something that comes from some slice of the Ruliad. Now, it doesn't mean that there's nothing objective because we are the way we are. So relative to us as humans, there are objective things that can be said. I mean, the notion that sort of everything has to be kind of relativized and can't be objective, I don't think is right, insofar as, if we believe in a collective human nature, that we are all observers of the kind we are, so to speak, and we don't believe, that there may be nuances of difference, but for human-like observers, certain things might be objectively the way they are. And for the whales and dolphins and dogs and cats and so on, it might be different. So I'm curious.
Absolutely.
That notion of objective reality, when people have thought about that, and thought about the objective reality for the cats and dogs, for example, is it imagined that, that there could be an objective reality for the cat that is a distinct objective reality from the objective reality for humans? Or is that something, I'm just sort of curious whether that's engaged with a kind of philosophical discourse.
Yeah, it is. And I think the debate is, it's just difficult and it's muddled. I think there's different levels we can have this, and there's a sort of a level of we can arrange the possible views by how relativistic or idealistic they are. At one end of the scale, every statement is relative to something, relative to our concepts or beliefs or whatever. At the other end of the scale, every statement would have an objective status, regardless of us, who we are, or whatever. But there's many views in the middle, right? So as I'm hearing it, the Ruliad view says there are at least some objective, completely objective statements, like the Ruliad exists. That's true. That's a fact, regardless of whether we are humans, cats, dogs, aliens, whatever.
Just to stop for 1 second on that, because it's a funny kind of fact, because it is a very abstract thing. It's like saying, do numbers exist?
Sure, sure.
right?
It's one of the most all-encompassing kind of statements about reality. Yeah.
Right, but it's in a sense, numbers are numbers part of reality, or are numbers an abstract thing that, you know, we could that, it doesn't matter whether you can have 10 pebbles, you can still have the notion of 10.
Mm.
And the Rulliad is of that abstract type. I don't know what, so to say that it is it's a fact that it exists is kind of a funny thing to say in a sense, because it's a
Yeah, yeah. But
because when you say it's a
yeah,
fact
yeah,
that it exists, it
yeah.
suggests that it could be the case that it doesn't exist. Whereas I don't
Oh,
think
no,
that's
I
a
didn't mean to. Yeah, I didn't mean to imply that. I mean, after all, it's fine to take some facts, the existence of some facts, as being necessarily that way. So definitely didn't want to imply that
okay.
in calling a fact, it could have been some other way. Yeah,
But okay,
and
so
I
so you
think,
you you
yeah,
identify a notion of sort of necessary facts, of which,
yeah,
you
yeah.
know, and which is already so that's a grounding of some kind of, uh, things have to be that way. These are necessary things. Given the
Yeah,
definition that we have, it's necessary, it works this way.
and historically, it's been unusual to identify physical facts with necessary facts. Necessary facts would either be thought of as purely abstract mathematical ones, or purely
Right.
abstract sort of ones about Platonic universals, or maybe something to do with kind of religious views. But maybe we don't call those things kind of physical material in the way that we are. And the material world has thought of being as highly contingent but there's historical reasons for that, rather than necessarily, you know, good reasons, right? There's space for the view that certain facts could be both necessary and part of the physical world. I mean, that seems to be where
Well, that's where
this
I'm
view
going
might
in a
might
sense.
live. Yeah,
Right. I mean,
yeah,
so, the rather bizarre kind of slice of sort of a metaphysical approach that, I've sort of backed myself into, so to speak, is is the idea that, the Rulliad is this necessary thing. There are features of sort of what underlies everything that are necessary, and but that what we perceive as the laws of physics are necessary insofar as contingently we are the way we are. So in
mm,
other words, if it's it follows from the fact that we are the way we are, which is something we can't derive. Well, maybe we can derive it a little bit, but assume that we can't derive it. We just, the fact that we're on this planet rather than another one is not a derivable fact. It just happens to be that way. And then the claim is because we happen to be observers of the kind we are, then it necessarily follows that the laws of physics have to be in certain ways the way that they are, which is I
and
don't know whether
thereby
that's
by
yeah.
laws of physics. There, if I've got this right, you don't mean the total rules that determine how the Rulliad works. You mean the laws of physics as physicists, write them down.
Yes, that's what I mean. I mean, in other
Yeah.
words,
So
within
yeah,
within the Rulliad, there are all sorts of, an infinity of exotic kinds of ways the universe works. It's just like, the fluid dynamics case is a very simple case, which is, we could be talking about the dances of all these molecules, but we don't. For observers like us, we say the fluid flows and obeys the laws of fluid dynamics.
yeah,
And it
yeah,
so happens that, historically, people imagined that you might be able to derive the second law of thermodynamics, which is kind of the underlying piece of that. People imagined from the mid 1800s that one might be able to derive that, and that it might be something that would follow from the laws of mechanics. For things like general relativity and quantum mechanics, that wasn't something any of us had imagined would be derivable. In other words, those things seem to be just, we got them. They got wheeled into our universe. We can't say why. And what I've now been realizing is that it is inevitable that for observers like us, general relativity and quantum mechanics have to be there, just as it's inevitable for observers like us that we don't consider all the individual molecules, we just think about fluid mechanics. I mean, I can be more extreme even and talk about mathematics, because I think the same is true of mathematics. That is, I think that the mathematics that we have is a consequence of the way that we are. So, for example, in mathematics, there are some axiom systems like the ones for arithmetic, pretty well established. It's pretty clear, intuitively, it's clear why one might want to talk about things that way. And something like set theory, it's much more abstract. And there are things like the continuum hypothesis, where it's very difficult to have an intuitive sense of how that should be. But I won't be surprised if it is the case that for mathematical observers like us, it has to be the case that the continuum hypothesis is one way and not the other. And that if it was the other way, that in a sense, we would not be able to have a coherent view of mathematics. So, for example, one of the things about mathematics that's non-trivial is, we can meaningfully talk about the Pythagorean theorem and just talk about the Pythagorean theorem without recursing down to say, and the real numbers are constructed this way, and we have this axiom and that axiom and so on. That's the analog of saying we can talk about fluid mechanics without having to talk about individual molecules.
Yeah,
and the fact that we can do that is, I think, a consequence of the fact, there's certain axiom systems of mathematics where we will be able to operate at the fluid mechanics level, and others where we'll inevitably get kind of shredded to the molecular level. And so in some sense, then the laws of mathematics, somewhat surprisingly, it could be the case that the mathematics that we choose to do is inevitably the way it is because we are observers of the kind we are.
So there's, that a whole bunch of ideas are just sparking. So let me see if I can put them in order. So we first a little bit about laws of nature or laws of physics or whatever you want to call them, and then a bit about maybe mathematics. Laws of physics, there's broadly two metaphysical ways of understanding what we mean by a law. One is a generative notion, whereby what a law is something that takes us from one state of the total state of the universe to the next. So the law, as it were, drives the universe along. The other notion is that a law is really just a way of summarizing what's happening. So reality is, so the phrase that gets used is, it's a mosaic. There's perhaps infinitely many different things happening, and the laws are our best attempt to summarize them, to capture as much information as possible in a neat as package as possible. So it's a trade-off between the how much of reality it gets right versus the simplicity of the rules that we can write down. After all, a law should be something that we can write down in some kind of language that's meaningful.
Well, actually, let me stop you there for a second. So, one distinction you're making is, when you try to explain a thing, one way to explain it is by mechanism. It happened this way because it went step to step to step. The other way to explain it is it has some overall constraint or some purpose or some such other thing, and you say, it has to satisfy this set of mosaic constraints, so to speak. I think I'm not sure that, to me, any law of physics, for example, can be stated in both of those forms. It becomes interesting. Some things I've been doing in biology recently, where biology has not had much of a theory, but in biology, there's a lot of explanation by purpose that comes from natural selection. And the question is, how does that relate to explanation by mechanism? And I think we just figured out a bunch of stuff about that, but that's off topic. Your other point about what is a law of nature, I don't know what the kind of prevailing sort of thought about this, but to me, a law of nature is something where we take the world as it is, and we are trying to create a narrative that will kind of somehow fit in our minds that explains why the world is the way that it is.
Yes, I think the more traditional approach to laws of nature is, as it were, trying to uncover that something inherent in the universe. So, to take a religious view, right? God had a plan, we're trying to uncover what that plan is. And maybe you take the religion out of it and you say, okay, no God, but still the universe has a plan, and we're trying to uncover what the plan is. And I think the way the philosophy, the metaphysics of laws of nature has gone is no. There is no plan there to the universe. Really, we're just trying to summarize what goes on in a way that makes best sense to us. And from that point of view, it kind of becomes something relative to us. What we're kind of asking is, given the kind of creatures that we are, what is the best way we can make sense of what has happened or what's going to happen for us?
Right.
So what counts as a good law of nature would be different if we were different kind of creatures. This relates to the kind of fluid mechanic example.
Right, but so a few things to take apart some of the things you were saying. So one thing is there was a plan for the universe, and it is up to us to discover it. That's one possible view.
That's a sort of a traditional view, yeah.
Right, but in a sense, the idea that there was a plan for the universe suggests that sort of there was a mind that picked this universe. It had a plan. It arbitrarily picked the universe as it is. And then it is, it went from the plan, which was pretty simple, to all the complexity of the universe. And then we're trying to put all that back together again and figure out what the plan was. I mean, is that a reasonable characterization of what?
Yeah, and I think this view, had its antecedents in religious views, right? Where it probably it's probably most coherent against the background of a divine creator, right? Because then you can literally talk about a plan in the mind of a creator without the kind of religious views.
That's very anthropomorphized mind. I mean,
absolutely.
In a sense, a mind that has a narrative that is capable, where, we're going to have a simple narrative that we can understand. Did the creator have a similarly simple narrative? It's far from obvious that even if the AI creator or whatever was there or something, this idea that there has to be a simple to simple kind of thing. I mean, it's interesting that so this question of why are the laws of nature simple, and I know that it's a kind of I know there's sort of argument by design type things about this is evidence for the existence of God, is that there is regularity in the universe. At least that's my impression. Maybe that's from and I mean, I guess that tradition of the laws of nature, the simplicity of the laws of nature is evidence of a divine intent, so to speak, is one explanation for the simplicity of the laws of nature. Another explanation would be the laws of nature are fairly simple because we're pretty simple creatures, and the only things that we could abstract from the natural world are those fairly simple things. So
I think the on the sort of second characterization of laws of nature I was talking about, where what it is to be a law of nature is to be something like a good summary of what goes on. We cut out all the noise, and we try to pack as much information as we can in a simple formulation. The reason laws of nature are simple is because that's what it is to be a law of nature. If we tried to write down a sentence that described every single matter of fact, it just wouldn't be a law of nature anymore, because it doesn't do that simplification process. Essentially it's like the AI summary, right? It's something that tries to capture the essence of what goes on in a short piece of information.
But it's not obvious that such a thing, I mean, in physics, we've had the luck of discovering what are fairly simple to humanly state laws that we can then build a giant tower on top of and actually find out that the world works that way. It is not self-evident that there should be some, that there should be findable simple laws. It could be the case, and it might be in biology, for example, that in biology and medicine, things like it's always an interesting change of intuition. In physics, the simple explanation is usually true. In medicine, for example, there's always a footnote to a footnote to a footnote. I actually think I have some understanding of a sort of foundational understanding of why it works that way. But the fact that there could be simple laws of nature is I think not self-evident. And
yeah. And the best evidence is, I mean, when people are talking about laws of, like, the fundamental, the basic laws of nature, they're usually gesturing towards fundamental physics, where it just seems to be a remarkable fact that we can find these highly reliable but still quite simple formulations. I mean, that is, there does seem to be some feature there that calls out for an explanation.
Right. Well, I
But
think,
yeah,
yeah, but I mean, so let's take the fluid mechanics example again, right? The microscopic molecules bouncing around, they do a lot of complicated stuff. The fact it is a mathematically derivable, although I think I more or less nailed it, but it's been flapping around for 100 years to actually do this derivation, that it really is the case that there is a simple description that will work for observers like us. It's not obvious that there couldn't be a miracle in the fluid, for example, where it more or less was doing that, but then suddenly it jumped out and did something different.
yeah,
Just like,
yeah, yeah.
right? But there is a potential mathematical derivation in that case that given what goes in at the level of molecules, what comes out at the level of an observer described in a certain way, an observer like us described in a certain way, necessarily has to be the laws of fluid mechanics. I mean, I think that's this idea that, I mean, in my picture of things, there's this whole notion of computational irreducibility. Even though you know the rules for a system, you might have to just follow every step of the computation to see what the system does. For example, coming back to time, my belief that the passage of time is the fact that the passage of time is in some sense achieving something is because it is an irreducible computation. To know what the universe is going to do next, you have to actually do it. You have to do the computation.
Mm,
And that's in a sense why the passage of time, why there's a meaningful passage of time. If what happened in the universe was always you don't actually have to do the computation, you can jump ahead and see what's going to happen, then there isn't this any kind of universal passage of time. The fact that if it was the case that some things in the universe you could just immediately say, I know what's going to happen, then in some sense that wouldn't have the same it wouldn't have the same feeling of the passage of time as it actually does. But that's kind of a sideshow. I mean, the point that I was going to make is that one necessary feature of the existence of computational irreducibility is that there have to be slices of reducibility. In other words, while you can't say everything about what's going to happen, inevitably you will be able to say an infinite number of specific things about what can happen. And
as
in a
it were,
sense,
locally.
yes, well,
Yeah.
they can be statements that are quite global, but they are only about some small part of what's going on. So you might say, it's I don't know, this pattern, even though the full pattern is computationally irreducible, this particular stripe has to have this form, and it has to go on having that form to infinity, but it's just that stripe, it's not the whole thing. And in a sense, the way I view, laws of nature is they are slices of computational reducibility in an otherwise computationally irreducible universe. But the fact that there can exist laws of nature is inevitable because there have to be slices of computational reducibility. Now, which creatures get attached to which slices, that's a very much more contingent thing. In other words, it could be that there are laws of nature that would be very appropriate for creatures not like us, which we can't even perceive those aspects of the
Mm.
natural world. If we could, we'd immediately say, oh, we know how the world works. It works this way. And that's completely orthogonal to our description of how the world works. But I think the existence, in my claim would be, the existence of laws of nature, of certain simplifying laws of nature, is inevitable. In other words, you couldn't imagine a universe in which there wouldn't be any conceivable laws of nature that were simple. Now, you might be unlucky in that you're a creature. Well, I don't think you can be unlucky, actually. I think as soon as you are a coherent creature, you have to be operating within a slice of computational reducibility. In other words, if you're a creature that is, stuck right into the computationally irreducible mess, you will not be a coherent creature. There's no,
Right. Yeah. Yeah. Maybe there's a thing there, but it doesn't count as a, uh, it can't think, or it doesn't sort of, wouldn't be something that we would class as a being, a creature, or whatever.
right. I mean, it necessarily doesn't have coherence because to say that it has coherence is to say that there's some reducibility, some regularity in it. So at least from our point of view, the thing that's, stuck in the computational irreducibility, certainly from our point of view, from our sort of type of reducibility, we'll just say there's nothing there. It's just random stuff. It's not, there couldn't be a coherent, insofar as we project of each other that we have a coherent inner experience, we don't necessarily project that a rock has a coherent inner experience, but we do project that other humans have coherent inner experiences. We wouldn't project that to this sort of lump of computational irreducibility. But so, the argument,
that's, yeah.
Actually,
really interesting.
Go ahead, please.
It's just one thing that sparked was there is this debate over in the philosophy of science, when we try to give explanations, we tend to prefer simple ones. Other things being equal, the simpler explanation seems to trump the more complex one. And there's a question of why that should be. In certain fields
of science, I should say, in certain fields of science, it's not true in the life sciences. In many cases.
Right. Yeah. I think there we're taking sort of physics as the sort of paradigm case.
Right.
Yeah. True. But there's a question of why we take that to be a good, rational move. After all, we don't have independent access to the way the world is, so that we can say, well, because reality is simple, the laws should be, because we don't have access to reality independently of the laws we use to describe it. And so one nice line that people have taken is, well, look, given the kind of creatures we are, we have the need to formulate things simply. And if we get lucky, if we're lucky, reality will be simple. But there's no guarantee that we're lucky. And this seems to mesh relatively well with what you're saying. It's not an absolute fact. It's rather just a sort of a given certain reducible bits of reality, we're lucky to be in one of them, and then we can kind of state these simplifying laws.
Maybe so. Maybe there's a little bit more one could say, because we are choosing to sample the universe in certain ways, and those ways, there's a relationship between the type of sampling we do, the type of perception we have, and so on, and the things about which we can make simple laws. So in other words, there would be things we might consider, like, I don't know, if we look at, olfaction rather than vision as our source of things, it could be that there aren't such simple laws of how fluids flow around and, smells go from here to there. But, the things that are our, so it could be the case that we have, for example, we have the perception mechanisms we have because minds of the kinds we have are able to make simple laws for the kinds of things that we perceive. And because we have minds of the kind we have, they're able to make predictions and so on. If our senses were very different, our minds wouldn't be able to make predictions, and we'd be stuck having to talk about, we build our world. We live in, we have built our world to be one in which we can live in, so to speak. And we also have chosen to sample those aspects of the world that are, that are ones where we can figure out how they work, so to speak. So in other words, that it becomes inevitable that at some level there are, I'm not sure there's a complete argument, but at some level it's sort of inevitable that the laws must be simple, because otherwise we sort of wouldn't be living in that segment of reality, so to speak. We could be, now it might be, the issue is really, there are certain choices we have about sort of where we live, and there are things that are forced upon us. So for example, I think it's inevitable that there will be slices of computational reducibility in certain kinds of systems, but maybe they're not useful. Like, for example, let's take brains as an example. We're doing neuroscience. We say there's going to be something computationally reducible about the operation of those 100 billion neurons we have. We say, well, yes, there is. It's the EEG pattern. Well, the EEG pattern is not particularly useful in knowing detailed things about how one thinks. It might be a predictable feature of the brain. It's not a particularly, for us, for the things we want to get out of brains, it's not a particularly useful feature. But, so that's the question, is there might be sort of laws of nature that exist and are simple, but they don't happen to be laws of nature that describe things we're interested in describing. But let's go back to the biology example, because
Yeah.
I'm not sure I understand. Because in biology, there really isn't, this principle of simplicity just doesn't work. And, it's it's kind of like when when you look up some medical question, you might say, well, is it this or is it that? And the answer is it's neither. There's a giant chain of footnotes.
Right.
And
So is it that the principle of simplicity doesn't work at all, or is it just that it does, but there's 101 exceptions to the general rule? So it is what changes from physics to biology. Right.
I think it just doesn't. I think that the idea, the Occam's razor principle that's worked fairly well in physics. Where does that principle work? Okay, so it works, it has worked well in the physics we've been able to do. Which is not to say it works in all possible physics. It works in the physics we've been able to do and we choose to talk about. Does it work in mathematics? Okay, you could say, anything, what would be the analog of Occam's razor? It could be anything that's interesting to talk about will have a simple proof. That's clearly not true, right? So it's
if only.
Right. Well,
yeah.
Be glad that it isn't, this is the thing, that computational irreducibility, which is what I see as being the origin of the fact that there are things that can be simple to state but are very long to prove, that's the reason that anything sort of in any sense meaningful can happen in the universe. If it was the case that everything that happens through time in the universe was predictable much more quickly than actually having that happen, then sort of what's the point of having it happen, so to speak? And in mathematics, if everything was low-hanging fruit, there would be no there to mathematics, so to speak. The thing that's there in mathematics is this layer of computational irreducibility that allows you to go from, in other words, number theory will be finished by, there would be no number theory if there was no computational irreducibility. You just state the Peano axioms for arithmetic and then say we're done. It's that computational irreducibility that makes there be a there for something like number theory. But I think the question, it's an interesting question, which I'm not sure I've ever thought about before, what the analog of Occam's razor would be. In a sense, there is a simple explanation. Yes. So that would be sort of the analog in mathematics, would be to say, is there a simple explanation for these things that we see in mathematics? And
I don't even, because we're thinking of, in the physical sciences case, we're thinking of, there is some phenomena that happens, and then there are the laws that we try to use to summarize them or to predict them, but there's a separation between these things, right? There's the phenomena, the occurrings, the happenings, and then there's the laws. Mathematics, what's the analog of the you could say there's the semantics and there's the proof theory, and maybe it's this sort of is that the analog? I don't really know. That we have some models and we have some axioms that try to classify the models. I don't know if that's the right kind of analog.
I think there's an underlying in mathematics, which is the axiomatic, very gritty steps of apply this proof element and do this thing and that thing and that thing. That's not a mathematics that almost any actual pure mathematician does.
Mm-hmm.
Actual pure mathematicians think at a more abstract level. They talk about the Pythagorean theorem rather than the 8,000 lemmas that you need to get it from set theory and so on. And so I think, the question then is it the case that in the underlying is all of that, axiomatic mess or subaxiomatic mess? The observed mathematics is the kind of thing that pure mathematicians can talk about.
So are we talking about the structures, as it were, the sort of Platonic, the numbers themselves, or aside from the Peano axioms? Is that kind of what we're thinking about?
I'm not sure. I think it's just, let's talk about triangles and how triangles work. And the very concept of a triangle is far above the axioms of geometry.
Sure, the triangle itself. Yeah.
Right. But but you could derive, given some axiomatic basis, you could say, let me set up the whole description of the triangle. Okay, it's there. I know the Pythagorean theorem is like 8,000 lemmas away from sort of the usual core axioms. So then I could say, well, in order to make progress, in order to talk about the next step in mathematics, I have to go down and percolate through all those 8,000 lemmas. But actually, the way people think about things from the Pythagorean theorem or whatever is just to say, I'm going to operate at the level of talking about geometry, even though, occasionally you get burnt that way. Occasionally there's something, you step on something which really does have to recurse all the way down to the bottom.
Yeah.
But most of the time, you can kind of float in the clouds, operating at this much less, operating at a level that is like the level at which we can perceive the universe. That is, in the fluid dynamics example, we perceive the fluid flowing, even though that's not what's actually there. What's actually there is a bunch of molecules bouncing around. And, I claim the same thing is true of the structure of space-time and so on. So then the question is,
and so I see. So you're thinking of the fine detail of the molecules analogously to the sort of the fine detail of the 8,000 lemmas that are needed so the triangle. So is the picture something like that? The triangle, the thing itself that we can have geometric intuitions about, is sort of something that lives at the level of the fluid. It's a sort of the cloud-like effect of all the lemmas. That's not how I was seeing it. But I'm more or less a Platonist, as in I would think of the triangle as the reality. That the real thing is the triangle,
well,
the abstract triangle.
Just like you probably think of the fluid as a real thing. And when somebody tells you it's made of molecules, you say, that's an amusing scientific fact. Doesn't make any difference to me pouring my drink type thing.
Yeah, but I think of the molecules as something that underlie and give rise to the fluid, whereas I'm not sure I would think of the axioms or the lemmas as something giving rise to the triangle in the same way.
Well, maybe
yeah.
You're thinking you start from the triangle, and that's your sort of base reality, and that the axioms are just constructed as a way to sort of scaffold that. Well, so
because after all, we can pick different axiom systems. We can conceptualize things, in different ways. Entirely different axiom systems might end up perfectly well describing the same kind of reality, the mathematical reality. So the axioms would be more like the particular laws of physics that we happen to formulate, but with the knowledge that we might have formulated our physics in a different but maybe equivalent way.
There's a direct analog in fluid mechanics. It doesn't matter whether the molecules in a fluid are this shape or that shape. The laws of fluid mechanics are still the same. It's the same type of thing. It's as you can have a level of description that is the fluid mechanics level, and you can swap out the microscopic details. It's there's kind of this emergent level that doesn't really care about those microscopic details. By the way, in your statement that there's sort of a there in the fluid, the intermediate case is the case of space. Is there a there in space? Right. So in our models, there is a there in space. Space is made of this network of atoms of space, whereas the traditional sort of Euclid style view is that there is no there to space. Space is just this background thing that allows you to attach points in different places, so to speak. So, from that point of view, it's, the fact that we have a view of space that you might say, I'm going to start from my view of space that is our Euclidean view of space. I'm going to claim that isn't the genuine thing that's going on in space, any more than, in some sense, when you talk about the triangle, the Platonic triangle, that's in some sense, there's an underlying to that, just as there's an underlying to space, which you might not have thought was there in space. Whereas, for the last 100 years, we've thought there was an underlying thing for a fluid. You go back further than that, people didn't know molecules existed until 100 and something years ago. So that it wasn't really known that there was an underlying thing in that case. But
I think this has been a really hot topic in metaphysics of physics, right? Is there a nature to space time, whatever? Is it just the relations between things, or is there a kind of a substance there? Do space-time points have an identity of their own, irrespective of their relations to the things that occupy them? That's been a real hot topic, and you get the kind of variations of sort of the bucket argument and the whole argument to try and establish one way or another. And I don't think
I'm
anyone's.
not sure I know those arguments. Tell me
Right, right.
Are you talking, is it a Marx principle type argument, or this is this?
Well, you're going to get me on my pretty shoddy knowledge of philosophy of physics, but the whole argument is whole as in whole in space time. The way the physics works, as it were, is pays no heed to, as it were, if we were to kind of imagine a sort of a map of the point of space time, and we were to kind of poke a hole in it, that'll make no difference to the underlying physics. So there can't be any.
Yeah.
Right. But
I mean,
I think that.
I mean, look, in traditional views of physics, the singularity at the center of a black hole is a hole in space-time, and it makes a big difference. If there wasn't for that hole punctured out of the manifold of space-time, there wouldn't be a black hole.
Right, I think.
But you're imagining something
different. We're talking about something different. I think we're just talking about the metric that we put over space-time could be, as it were, rearranged in certain kind of equivalence preserving ways, as it were. So what this argument is, I'm making a really shoddy attempt at presenting it, but what it's pushing towards is that the exact identity of the space-time points makes no difference. It's just the distribution of things over them that we care about. So as it were. When we look at a model of relativity, right, the space-time points are a mere mathematical artifact. That's meant to be where we're pushing it. There's no reality there. There's no physical reality to them. We could, as it were, swap them out for something else without any physical loss.
Right. So I mean, in our models, we kind of start from the idea that there are atoms of space. Actually, it's a little bit more slippery than that. Because what really matters to us is that there are events that happen. There are relations between atoms of space, and there are events that take different atoms of space, kind of have them be reprocessed to rearrange the relations between atoms, make new atoms of space with new relations. There's some event that happens, kind of that is the elementary thing in the universe, is these events, which are the result of
the events and the atoms of space-time aren't the same thing.
No, the atoms of space are. So the atom, there is a hypergraph, a network of atoms of space, and then there are rules. So that's sort of the extent, that's how space is made up. But then there are rules that say, if you have a little piece of network whose atoms of space are connected in this particular way, then it will be replaced by a piece of space whose atoms of space are connected in some other way. That's the basic computational process. Who's running,
because these are literally atoms of space, not space-time, which is right. So because one of the things right. I mean, one of the things that I think was sort of a wrong turn in the early 20th century in physics was this packaging together of space and time. Yeah. The discussion has sort of taken that for granted, that the points that we're arguing about the reality of are space-time points. So your picture is a kind of an interesting kind of hybrid, in the sense that we have these space points, but something happens to them. They can be transformed in time.
Right. And these events that happen, these events take some collection of atoms of space, reprocess them and give other atoms of space. That produces a causal graph. There is a causal relation between this atom of space that you needed this atom of space to exist in order to create this other atom of space. And so the thing which is ultimately the the closest to being a sort of hard piece of reality is this causal graph of the causal relations between the events that happen in the universe, so to
Right.
speak.
Because
And
that was
then,
going to be my follow-up question. The level of these space points and the events on them. This is, as it were, hard facts. It's not relative to us as observers, the kind of things we are. This is happening for any creature
well, yes, but
objectively.
okay, it's a pretty deep rabbit hole, okay? Because in okay, the first statement is there is a causal graph. There are certain events, they have causal relations to other events. That is essentially a space-time causal graph. To reconstruct something that we consider to be the instantaneous structure of space, we have to take a slice across that. We have to decide which events do we say have happened by now. And that defines, that defines our simultaneity surface. From that, we can reconstruct what we consider to be the hypergraph that represents the current structure of space. So that's kind of the picture of how that arises. One of the sort of the tricky things about this is all we're saying is there are certain update rules that can be applied to this network, but those update rules can be applied in many different ways. And so you essentially have many threads of time, many threads of history. There isn't just a unique sequence of updates that can be applied. There are many possible branching and merging, threads of history. And that's what ends up giving us quantum mechanics. And people say, oh, time seems to be one-dimensional. Time is not one-dimensional in our models. Time is similarly this complicated thing. We call it a multi-way graph. It's a complicated graph-like thing. The fact that we perceive time as one-dimensional is another one of these things that is a consequence, I think, of the fact that we are kind of observers of the kind we are, who notably believe that we are persistent in time and have a single thread of experience. It's kind of
Yeah.
interesting that we perceive time to be single-threaded when one of the fundamental features of us is that we believe that time is single-threaded, so to speak. I mean, it could be the case that we would be running multiple threads of experience in our brains. We don't. If people start to do it, they kind of, seem to other people to be going crazy type thing. In other words, the idea that you could be running multiple threads of experience sort of in your mind at the same time is not something that we typically do. And I think that's, that.
And what about so the way you've described, all of these kind of causal arrows, the way you're describing time there, it seems, even if there's not one dimension of it, it seems to be very directional.
Absolutely.
Because this
Yeah.
is this is a this is a huge question, right? It's not just the existence of time, the nature of time, but the direction. Like, is there some objective direction, or is it just the fact that entropy goes a certain way? Is it possible that time runs in contrary directions in different portions of the universe? You seem to have an
No.
objective direction there.
Right. I mean, the universe is okay. There are different ways to think about it, but in terms of the idea that there is this computation that is getting done. You start from the initial thing of the computation, and how do you work out what's going to come next in the computation? Now, the computation could be a reversible computation. It could be something where, in principle, you can run it backwards, but both directions are computationally irreducible. It doesn't really help you to say, and it's like talking about the law of, the second law of thermodynamics. You can say, well, typically you start from something that looks simple and it ends up looking complicated to us. You can go to a lot of effort to make something that looked complicated at the beginning that will be carefully arranged to evolve to something simple. Both to know what the simple thing is. Okay, the picture of the second law, I think, is the reason we believe in the second law is because there are computationally irreducible processes going on at the level of molecules bouncing around, but we are computationally bounded observers. So to us, even though in principle, you could reverse the computation and you could see, oh yes, this configuration of the gas that I'm seeing really came from this very simple special thing. We can't in practice do that because we are computationally bounded. And so it's because of the interplay between the computational irreducibility of the underlying dynamics of the system and the computational boundedness of us as observers that we say, oh, it just looks kind of random to us. In other words, if we were observers who were not computationally bounded, we would never say the configuration of molecules in the gas look random. We would just say that configuration of molecules is the one that came from this very simple initial condition. But it's because we are computationally bounded that we can't do that. And so the only thing we can say is looks random to us. And I think
so from the Rouliad point of view, as it were, it's a different kind of picture. The computational steps take you in a non-random way. Randomness is a perspective.
Right. In the whole Rouliad view, you might sort of say the God's eye view in some sense. None of this happens. In other words, let me play a different aspect of the second law of thermodynamics. Back from the 1860s, when people were first talking about it, they were immediately worried about the heat death of the universe, that the universe is the way it is right now, and it's all very organized, but in the end, everything will decay into just heat. And they're like, that's a problem, so to speak. But what is heat? Heat is a bunch of molecules bouncing around to us randomly, but they're not bouncing around randomly. They're bouncing around in a way that is the future of some very elaborate dance that was happening in the molecules earlier. It's just to observers like us, we just throw up our hands and say, it's heat, it's random. So in other words, the heat death of the universe is a phenomenon about observers like us. It's not an intrinsic phenomenon of the universe, so to speak. So I think, and I think that's some, but I mean, coming back to this question, I mean, I think we've gone through lots of different kinds of things here, I mean, this question about laws of nature, I mean, I'm curious about the kinds of things that people have thought were necessary, which I suppose also relates to questions about why the universe exists. Is it necessary that the universe exists? Things like this.
Yeah. I mean, it's very easy to characterize, the abstract world, mathematics, if it exists in any sense, as being necessary. Whereas, like we were talking about earlier, the physical world, our world, is much easier to characterize as contingent. So, utterly contingent. So, why is it this way, and why is it there at all?
Right. Well,
that's one kind of question.
Right. I mean, my argument of why is it there at all is the thing that is unsurprising is in a sense, the Rouliad has to be there. What is not obvious is that observers like us have to exist within the Rouliad. But the fact that observers like us can exist, at least, will exist within the Rouliad, is something you can imagine essentially mathematically deriving. In other words, to know that there can exist. I mean, I've been sort of surprised recently to realize that I think self-reproduction, which I had always thought was a kind of detailed, biological kind of thing, I think it's actually more important to the existence of reality than we might have imagined, because the fact that there are lots of us who can agree on something we can think of as objective reality, the fact that there are lots of similar us is really pretty important. If there was only one of us, I'm not sure that, I'm curious what you would think about that. If there was only one of us, is there any meaningful sense in which there can be an objective reality? Or does it require some kind of, multiple triangulation, multiple sort of minds?
Yeah. I mean, if we're meaning objective reality in the usual sense, it's objective kind of implies observer independent. If there's an objective reality, then there would be an objective reality regardless of the number of observers. What seems to require a whole number of observers is to meaningfully make sense of it, to interpret it, maybe to think about it, right? Maybe if there was just one observer, you wouldn't be able to. If you were the only observer, could you even interpret anything?
Well, right. I mean, but I think my point of view is, with respect to the Rouliad, you could be in many places in the Rouliad. So it's not, the fact, and it's an all possible worlds type of thing. So you could get any of those worlds, and you could say, to you internally, sort of imagining what's going on, you could say, well, it could be this world, it could be that other world. You don't have a way to anchor your view of what's going on. Okay, so one way to think about it is you could have made up for yourself a story about what's going on, and that story, you have no way to invalidate that story because there's nobody else who can compare that story with. And so that story could, in fact, be a correct representation of what was really going on. It could be something just all in your mind. And the fact that there are, I think having these sort of multiple entities that all claim the same story, so to speak, it's not a perfect argument because you could say they're all made up, so to speak, but it is at least it starts to have a weight of evidence that they all made the same story.
I think to have something like a concept of reality, right? So not reality itself, but where does our concept of objective reality come from? Well, the fact that there's many of us triangulating on something and creating meaning by talking, and that's important, right? I mean, a single observer somewhere in the universe on their own, I mean, from their point of view, what's the difference between their own thoughts and reality? It's only when somebody else comes along and you recognize them as being, oh, here's a creature somewhat like me, but they disagree. We're disagreeing, and then a third person, we're all. Then you sort of think, well, hang on, we disagree about some things, but we are agreeing on certain things. So this gives me a concept of there might be this notion, reality, that can disagree with all of us, and then we can investigate reality and see what's there, and try to, maybe we can try to fine tune our thoughts to agree with reality, or at least to kind of like intersubjectively agree with each other.
Right. I mean, I think this question of whether, is it inevitable that the universe exists? And, the Rulliad, the existence of the Rulliad, I believe, is something that, just as sort of a formally necessarily exists in some sense. The question of whether within a Rulliad must be observers like us, one could imagine deriving that. And then the question is, well, you can imagine deriving a lot of things. We don't know how to do it yet. But for example, one question you might ask is, is it, there could be many kinds of observers, like, the search for extraterrestrial intelligence. We're looking for alien intelligences. We say they're in a different star system. They're far away in physical space. We could potentially derive things like what is the density of certain kinds of observers in the Rulliad. So we could say, it's kind of like it's inevitable as a certain density of the observers that have a certain, that the reason we haven't detected alien intelligence is because the closest alien intelligence has to be this very great translation distance away from us, so to speak. We can imagine deriving those things. We haven't done it yet.
As in deriving it from the what are we when we say deriving it? We're meaning from some sort of statement about what the Rulliad is, or that the Rulliad comprises every.
I mean, the abstract nature of the Rulliad as this, all possible computations. We can actualize that. We can make we can say, we can represent it in terms of Turing machines. We can represent it in terms of something else. And then we can simply say, in the vastness of the Rulliad, what, can this particular kind of thing happen? And we can answer that question. So in other words, one thing that's sort of interesting maybe is what's possible and what's not possible. I mean, are there things where one says all possible worlds, to a Leibniz, for example? I don't know whether he imagined, did he imagine that there were simply impossible worlds? Or was his view of all possible worlds?
The super interesting question here is, what are the rules of, are there absolute hard and fast rules of computation, right? Like, so, as it were, are we assuming a sort of consistent mathematics or a consistent theory of computation? As it were, in deriving things, are we allowed to use rules like reductio ad absurdum? Like, we get a contradiction, something's gone wrong, we've proved something. For those kind of principles to...
Right. I mean, I have a very mundane point of view about what we can assume, which is basically we imagine we have some essentially data structure of the universe, and we are doing operations on that data structure, and that's all we get to do. And any kind of thing where it says, for example, let's imagine we're going to use induction. Maybe it works, maybe it doesn't. It's just a question, we can go step by step, and we can see what happens when we apply these, constructive operations on this thing that is the sort of data structure of the universe. To ask a question about what happens infinitely is we might be able to, is a question of how, what kinds of things can we assume? I think, I'm trying to think, reductio ad absurdum is a problem because it requires a notion of falsity, I think. And that's a can of worms.
Yeah.
In my view of the sort of constructive view of mathematics is, from the axioms, I can build certain theorems. What is falsity in that picture? My best effort at thinking about that is to use the idea from the Middle Ages, material implication is something where if A implies B, then if A is false, it implies everything. And so in other words, if you have a false premise, something which you identify as a false premise, then essentially everything becomes derivable. And so my picture would be this, that it's kind of like a white hole in physics, where it just, instead of a black hole, which sucks everything in, a white hole spews everything out. And the idea would be, if you're a mathematician trying to figure out how things work in the world, you have a bag that collects the theorems you believe are true. And you're putting things in the bag, and so long as that bag fits in your mind, all is good. As soon as you put a false premise into your bag, the thing explodes. And,
oh, wow. Yeah. So not just a contradictory premise, but a materially false premise.
Yes, but I think a contradiction, I don't know quite how to think about that. I've never liked this thing about material implication having the feature that a false premise implies everything. I've always thought that was kind of a silly setup. But, if we're talking about truth and falsity, I think we're forced into that setup. And I think in traditional truth and falsity and standard logic, I think we're forced into that setup. And given that setup, we will have the feature that if we seed things with this false premise, we're going to generate all possible theorems. From A equals B for arbitrary A and B, we can derive everything. And so then my picture of it is, what does falsity do? Falsity explodes the mind of the mathematician, so to speak. In other words, it isn't that you can't, that's the signature of falsity in a constructive world. I don't know what did the constructivists like Brouwer and so on.
They had a notion of absurdity, which, in the case of mathematics, I suppose falsity is not contingent falsity. So we tend to call it absurdity nowadays, and it's represented by, any contradiction. So falsity in constructive mathematics basically just means a statement that implies the absurdity, the absurdity, or an arbitrary contradiction, P and not P.
Which is a mess. And from Brouwer's point of view, that, he sort of denies the law of excluded middle. So where does he go on the P and not P? How does he get something that is what you're calling an absurdity?
Yeah.
How does that work?
It's more or less, so we start with a notion of absurdity and get negation from it. So it's not like you can use negation to define up absurdity. So absurdity must just be the thing that is guaranteed to be false, if you want to use the notion of falsity, but you don't. Or it's the thing that is, as it were, beyond the pale, if you're thinking just in terms of giving reasons. The thing that we're not...
What in mathematics is beyond the pale? In other words, mathematics...
Well, that's a good question. That's a good question.
Right. Mathematics is something where, as Hilbert would put it, you can define rules for tables and chairs, just as you can define rules for numbers and so on. It's, tables and chairs are, again, physicalized things where we have a sense of how they should work. But in mathematics, we can, in principle, in the Hilbert view of mathematics, which I don't necessarily share, because my view of mathematics is this view where sort of the human element has to come in, because it isn't the case that we can pick arbitrary axiom systems. There are axiom systems that are consistent with us being able to have a coherent mathematics, and there are ones that are not. But in the picture that we can pick any axiom system, so okay, this beyond the pale notion, I mean, it seems to me, in my view of things, there could be something which is beyond the pale, because it's something that is completely inconsistent with a humanized view of mathematics. But from a Hilbert point of view, I'm not sure that can
I think Brouwer took 0 equals 1 as the sort of stock absurdity. Whether that's justified because you say we just know it's not true, or just because it's sort of reached the point at which you can't explain further, I don't know what he would say there. But much of what Hilbert was trying to do was to show that here's a reasonable foundation for axiomatic foundation of mathematics that can't prove 0 equals 1. So that kind of notion was important to all those guys. For Hilbert, he didn't want these abstract notions of truth and falsity. He really wanted symbolic manipulation. So a proof, what he was going for is a proof that this system wouldn't derive 0, the symbol 0 equals 1, and the meanings are just whatever arise from the mechanisms of the proof rules.
But the fact that 0 equals 1 is a, without the Peano axioms, 0 equals 1 doesn't have anything to say. I mean, in other words, I could imagine some abstract mathematical system in which my 0 object could be equal to my 1 object. It has to be there have to be,
or at least the symbols could pick out the same thing. Yeah.
Right.
Yeah.
So, I mean, I don't know how you can have this question of sort of given an axiom system, one can have a mathematical impossibility. I claim without an axiom system, it's kind of hard to know what that could possibly mean, unless you're grounding your mathematics in something humanized, for example.
I think that's a great question for Hilbert, because for him, in some sense, as a formalist, for him, mathematics was just the symbolic systems that we write down. For Brouwer, it's much more about the human mind. Numbers are, as it were, constructs of the human mind. And, like we talked about earlier, he was influenced by Kant and thinking about this intuition of pure time and pure space. Geometry corresponds to space, and arithmetic, the numbers, to time, the passage of time. So, as it were, we start with 0 and we kind of clunk once forward. One mental operation in time gets us to 1, and clunk, we go to 2. Well, those aren't the same things. And that's just a basic given fact of the structure of the human mind. The first clunk giving us 0 and the second clunk giving us 1. They give us different mental objects. So
that's a very bizarre. I mean, I actually didn't know that connection. I mean, the claim that our perception of the passage of time is related to our perception of to our construct of successive numbers is, that seems.
there's a lot going on in Brouwer. I mean, Brouwer, he's been hugely influential in constructive maths and proof theory, but there's also a really interesting Kantian philosophy, which is highly, original and very, very bizarre, radical, out there kind of stuff.
That's interesting. I mean, but this notion of our experience of the inexorability of the passage of time being somehow related to the inexorability of successes of numbers is interesting, because I'm not sure that, I'm trying to think, if we were, we imagine computer systems that have many, distributed computer systems where there are different, instructions running at different speeds in different places and so on. The notion of the inexorability of the progress of time is really not, I think, present in the same way there. And so it's sort of bizarre and interesting.
Yeah, sure. I don't think it holds up. I mean, I imagine, I don't know, but I imagine what goes on is that the guy read some Kant and saw an idea and ran with it. You know, oh, there seems to be something similar in these notions, so I'm going to make something out of it. But I'm not sure it holds up at any kind of deep level.
Yeah,
Yeah, I wouldn't build a philosophy on it.
fair enough, fair enough. We've been going for a long time here and talking
Have
about
we?
lots and lots of different.
Oh, we have. Yeah, we have.
Yeah,
Yeah,
yes,
that's
I'm
what happens when you get talking. It's fun. Yeah.
yeah, right. And we've covered lots of different things. I mean, I'm somehow I think um, yeah, there are many kinds of questions here. I mean, I must say that I'm curious about sort of the things like why does the universe exist? Why is there predictability in the universe? Why is the universe not full of miracles? These kinds of things.
Yeah.
I'm I mean, one thing, you know, there are presumably threads of philosophical thought that have been going for a long time trying to answer those questions. And I guess that one thing I'm most curious about is sort of how, have those threads been spiraling around, or have they been sort of making forward progress through time? If they have been making forward progress through time, are they, you know,
That's a nice question. Yeah. I mean, it's hard to see what progress in philosophy would look like, since philosophers aren't on the whole in the business of making theories that make testable predictions. That's tends not to
I
be
think the
the aim.
testable prediction test is a terrible test. I mean, I
Okay,
think it's a
right.
terrible
Well,
test for
that lots of
science.
philosophers would like to hear that. It's really, we want, you'd like to come up with a theory that really seems to explain something that you didn't understand before.
Right. I mean, I think that one argument is when philosophy is successful, it turns into science. I mean,
Yeah,
in other
that's
words,
one picture. I mean, I think the other picture is that when you have a theory that is somewhat, an explanation that is somewhat successful, what you really do is you uncover further questions.
right. I mean, I
Um,
think one of the things about science, particularly physics, is it's a thing where it's been possible to build this huge intellectual tower. Same with mathematics.
yeah,
Something like biology, it's less true. There are many facts you can know, but it's not like you build a giant tower of, this thing implies this thing implies this thing. It's more like we've
right.
got another fact to know here. And I think, a question for philosophy is, how tall are the towers? In other words, the fact that people, in physics, you know, people aren't still studying Aristotle when they learn physics. In philosophy, people are still studying Aristotle. And I mean, as a personal thing, I might have mentioned this to you at another time, but my mother was a philosophy professor in Oxford, and so when I was a kid, I was very down on philosophy for the reason that it didn't seem like it had made progress in thousands of years. Um, it's I think that so I mean, it's very, this idea of intellectual towers that get built, which has happened in physics, it's happened in mathematics. Um, you know, I have the impression it's happened a bit in philosophy, but the question, I mean, there's certain kinds of things where I feel like, our recent efforts to scienceify various essentially metaphysical type questions has the possibility that you could just have a tower. You could say, this is this is true about time, and therefore this is true, and therefore this is true, rather than having to go back to the beginning again. But I'm
Yeah,
curious to what
yeah.
extent philosophy in its own development has kind of successfully built, what are towers that got built? I mean, where you say, Aristotle, we don't have to look at him anymore. Kant had the next step.
Yeah,
We
no,
can
it's
see.
definitely not that kind of picture. I think the kind of, I mean, it's a big question, where, if anywhere, does progress exist in philosophy? And I think it's much more about clarifying and uncovering questions. That's the progress. Uh, if you had a very successful philosophical theory, probably the consequences of that would be, to some extent, greater understanding. But really, what you'd have is a whole bunch more questions that you then want to go out and investigate. Whether they would be philosophical questions or more empirical questions, maybe some bunch of, some combination of both. I think there are, debates do get settled, or at least they settled down for a bit. There were mid 20th century huge debates in the philosophy of science about um, uh, what sort of attitude should we take to, what were called unobservable entities, right? So are there really electrons? Um, you know, to some extent, scientific realism kind of won out there. Um, at some point, there were philosophers, Berkeley, who were anti-realists about tables and chairs and things. And I mean, it's hard to imagine it now, perhaps, but those views were taken very seriously as true descriptions of the world. But they've largely become historical curiosities.
But I
Um,
think this question about reality, I mean, Boltzmann in his later life became a philosophy professor and was talking a lot about, because people had attacked him for the idea that atoms were real. And so he
mm.
was like, does it actually matter whether atoms are real or not? What does it even mean for something to be real? I mean,
Yeah,
in
this is
my
the kind
own
of instrumentalist approach to philosophy of science that, the question of existence and reality is neither here nor there.
Right. I mean, I think what happened is that, pre-Newton, pre-Galileo and Newton, it was like everything just has to, there has to be a thing there. There has to be a crystal sphere or something that's actually there.
Yeah.
Then it was like, oh, we can just make this mathematical, abstraction of things. And that allows us to do science. And there doesn't have to be a there there. I mean, I find it kind of amusing in my own kind of trajectory that I've been much involved in thinking about sort of computation as a foundation for thinking about things in science as opposed to mathematics. And I kid you not, it's still the case that people will sort of come up to me and say, how can the universe be computational? Where's the computer it's running on?
Right.
Maybe that doesn't, to me, that's a kind of a denial of what people have believed in science. Well, since, the times of Galileo and Newton, where they went abstract, so to speak, in their description of the world. It wasn't the world actually is solving a differential equation. It was the differential equation describes how the world works. And I think this question of whether, this sort of discussion of whether it is merely whether you're looking merely for a description, whether you have to be able to pick up, in our current situation, if you can't pick up an atom of space, is that a problem?
Yeah.
Well,
Yeah. Yeah.
the
Yeah.
the the fact is that no, we absolutely cannot pick up an atom of space. Observers like us cannot pick up individual atoms of space. Just as a practical matter, observers like us, well, with a lot of effort with atomic force microscopes, we can pick up individual atoms of matter. But generally, in our everyday experience, we can't pick up atoms of matter. And the question of whether there's a problem in a theory in which its elements are not things that you can. I mean, I suppose one of the things about science, we're, I was trying to wrap up, but we were not
We've gone
even.
down another rabbit hole. Yeah. Yeah.
But I mean,
Yeah.
this question of what kind of whether well what yeah whether the things that you are talking about in science have to be things that you can kind of separate out. In other words, one of the key ideas of science, it seems to me, in exact science at least, is that you can make idealizations. You can say, I'm going to look at
Hmm.
this small part of the universe without having to worry about the rest of the universe. That's kind of an implication that you can pick up one part and say, I've got this thing and I can talk about this electron independent of the rest of the universe. Um,
Yeah.
that's the
But
thing
maybe
that
there isn't an independent entity in any meaningful sense there.
Yeah, right. I mean, maybe the
Yeah.
entity is only has its, only exists relative to lots of other entities. Or, if you say, what's the essence of a living organism? Let me pick up, what's the essence of, I don't know, what's the essence of a mind or something? Let's pick up this one, mind core somewhere that is going to be this thing that is that's a sort of a it's like the idea, like the religious idea of souls, where you might have said, if there is a soul, where is it? Let me pick it up. right? Which is a wrong thinking idea about what kind of a thing that is. And
I
I
mean, I
think
guess we think that way because we each have our own perspective. But you know, there is this traditional idea of holism, right? That everything is interconnected, and the identity of a thing, insofar as you can talk about the identity of a thing, is bound up with the identity of, you know, the whole universe, perhaps. And there's been a lot of thinking that, well, maybe, you know, the nature of fields are like that, right? They're defined right over space time, and if everything in some sense depends on them, their interconnectedness, you know, maybe reality is a lot more holistic than we at
right.
our location in it give credit for.
Well, I mean, it's a kind of conceit of science that you can do. It's a conceit of experimental science that you can do independent experiments. Not obviously true. In other words, you know, people are very concerned, can you do a reproducible experiment in science? Well, if every experiment was not separable from the rest of the universe, then inevitably, you know, you can't, just
Yeah,
like you
yeah,
can't
yeah,
step in the same river twice or whatever, you know, you can't do the same experiment twice.
yeah. But it's probably, you know, if we are going to do the project of describing, theorizing, making meaningful sense, you know, we have to use language or concepts, and the nature of those things seems to be to label particular bits. So, you know, that might just be reality itself might be radically holistic, who knows, right? But it might just be a feature of the kind of creatures we are and the minds that we've got, that we have to treat it as being to some extent separable, even if the reality isn't like that.
Well, I mean, I see concepts as being a bit like this question of motion, particles, and so on. You know, you have an electron. The remarkable thing about an electron is you can move it around and it's still an electron. In some sense, a concept is something a bit like that too. You know, there is something formed in my mind that is an idea of an elephant or something, and yet somehow I can, it's some set of neural firings in my brain that is the idea of an elephant, and then somehow I can package that up and send it to you and have it arrive at a different mind, sort of move through the space of possible minds to arrive in your mind, be unpacked, and give you the idea of an elephant as well. And I think it's kind of like this notion of pure motion. The existence of concepts is like the existence of, you know, things like particles, which are kind of carriers of pure motion. And that's the way I kind of see it. It is not self-evident that, just as it's not self-evident that there would be kind of carriers of pure motion in the universe, that there would be things that can move and not change, it's not self-evident that there would exist sort of packagings of neural firings or whatever that could be, you know, packaged up and move and then be unpacked and somehow be the
Yeah,
same kind of thing.
yeah. I mean, the very existence of meaning is quite surprising in a way. But yeah,
Right. I mean, I think that, but my view of that would be it's it's it is a very similar thing to the existence of particles in physics. It's this thing that we can, it is another feature of the existence of slices of computational reducibility. If everything was irreducible, there is nothing that we can think of
no,
as
no
meaning,
meaning. Yeah, yeah,
because meaning is a compression of it's a way of sort of saying in a sort of human narrative kind of way what's going on. I think one of the questions, which we're not going to get into right now, I suppose, if you look at, your average neural net and what's going on inside it, which is, like a brain, except you can take it apart much more easily. There's the question of is there do you see the engrams of meaning inside there? In other words, is there something in there that says, oh, that's a sign that this. So, a very practical question I happen to have been looking at recently is, if you have an untrained neural net, it has some, you give it some random distribution of weights. Then you train the neural net. You look at it and you say, if I just am given a lump of neural net, can I tell if this neural net has, knows about, the works of Shakespeare or something, or knows
yeah.
about
And so,
something
is
that
the
we can
concept something in the net, or is it something in the way that the net then interacts with its environment? I mean, there's this long-standing idea in, philosophy of language that I guess kind of going back to Wittgenstein, that meaning doesn't reside in brains or minds. It's the interrelation between speakers or thinkers. So it's a sort of an interconnected thing. If we're all the nodes in the network, you need the whole network for meaning to reside, rather than just what's going on intrinsically in each particular brain or mind.
Yeah, I mean, I tend to think that the anchoring of meaning might require that, in the sense that, if there are only, three speakers or whatever, and they each have a slightly different idea of what a tiger is, there's probably not an objective version of what a tiger is. By the time you've got 1 million people talking about tigers, and it's sort of, there becomes a more, it becomes a more stable concept, even though it might not be precisely the same. People might not have precisely the same idea.
Yeah, anyway, this kind of idea of triangulation. Yeah, I mean, Wittgenstein had this argument that you couldn't have a one-person language. You couldn't have a private language. But we're talking here about big numbers. Needing big numbers to have a meaningful language.
Right.
So anyway, I think that's probably
it's a good question for an AI whether it can have a private language. So in other words,
yeah.
Right. So I think the answer is it can, and in the following sense, that if you say, I've got this AI and I want to, summarize the context that went into this AI, and then I have this, autoencoder that compresses the thing or whatever else, you can, in some sense, it can have, if it wants to remember what it knew in the past, you can say, I'm going to have these kind of lumps of compressed data that I can then recall in the future, so to speak. So in other words, you can think of that sort of lump of compression as a repeated thing that is kind of like language that we transmit. So in other words, the AI can have a language that it uses to communicate with its future, just as we might use a language to communicate between different entities ourselves. Right. And I would claim that even for our own purposes, as we think about things, we have to have we have to concretize our concepts if we're going to remember them for the future, so to speak, I think.
Just really interesting because, that discussion of, the AI that recalls and talks to its future self, really strong parallels with these examples that Wittgenstein uses. He talks about a guy with a diary and he writes down the sensations he's having, and parallels there, but arguing for completely different conclusions. So,
really? Just what was his conclusion?
His conclusion was that you might have this diary where you write down a symbol every time you have this sensation, but that's not enough to establish a language, because who's to say that you're using the symbol correctly? You're the only adjudicator of whether you get it right or wrong, and that's just to say that there's no criterion for using this language correctly or not. So his idea of a language would be something that needs some kind of independent criterion for is the word used correctly. Independent in the sense that it's not like God comes down and does it, but we can check each other's use of language. The idea of many nodes kind of working together.
Right. I mean, that doesn't seem right, because the fact is, if the goal is, can the AI remember what it was thinking before, and can it do it by having a very compressed, by compressing that data a lot? If it can compress the data a lot and sort of remember what it thought before, that's a pretty good, that's, now you say, what you're saying is it can remember what it thought before, in the sense it can be back in the same state that it was before. It can recover the state it had before. Now, does it have is there a there? Is there some, externalizable meaning to the whole thing? I don't think, that's a different question to whether it has a useful way of summarizing its thoughts, which, I mean, so it is a reasonable question, whether a language is sufficient, it is sufficient to say it's a way of summarizing thoughts, or does it need to be a thing that allows one to take those thoughts? Well, okay, so here's a version of it. I mean, if it is supposed to be transportable to another mind, then it may be a different thing. Then may need to be, maybe that AI with that particular neural architecture could successfully package its thoughts one day and recover them 3 days later. Whereas if it's taking it, that's a good point. I mean, if one takes it from that AI to an AI with a different neural architecture, You have to have a different kind of thing to be able to unpack
Yeah.
it successfully.
Although, I mean, if that's the criterion, then of course you need more than one AI, because it's sort of built into the meaning of the
Yes.
criterion that we need more than one. So, you know, somebody going for Wittgenstein's line couldn't assume that would be question begging. But I mean, what's really interesting here is it just puts a whole whatever you think of the sort of Wittgenstein gave very little in the way of evidence, linguistic or otherwise. It was very much just a conceptual argument. But here are some sort of ways of looking at it which are much more. Well, there might be some ways of testing this, or at least putting a new spin on it. Yeah, didn't think we would get into philosophy of language tonight, but there you go. Who knows where it's going to go?
Right. Let's see. I think maybe we can see that. I think there were some questions we can try. Otherwise, we should
Okay.
put where we're ahead. But let's see. Can somebody post the questions that people have been asking? Or oh boy. All right. Let me just see if there are. I don't want to get um let's see. There are a lot of things we have actually covered here. A lot of people here commenting on what is the most fundamental one? Can one get below language? And boy, okay, I think this is many more hours of discussion. Yeah. Questions like, are numbers a discovered truth? Interesting question.
Right. I mean, these are questions around the issues we were talking about of essentially realism and anti-realism, right? We can apply that to the physical world. We can apply that to numbers. You know, are they objectively real, or are they the products of language or the mind? Well, you know, philosophers disagree, right? There's the Platonist view of mathematics where numbers are just independent of our minds. They're objective reality, although abstract. And then there's the more constructivist view, like we talked about Brouwer, where numbers are mental constructions. For somebody like Hilbert, they were probably best described as just symbols. You know, there really are no numbers. What there are marks on a piece of paper. You know, you go mark, 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 and then you sort of extrapolate that into the infinite. And that's really all you can say about numbers. All the views are out there, and if the question is which one's true, you're going to need another couple of hours for that.
Right, right. Well, I think the view that I've been developing of things like mathematics is sort of the thing I've found interesting about it is it slips in between what I think are the established positions of a bunch of these different schools, which I consider as both interesting and somewhat encouraging, in the sense that it's not like, oh, those guys were wrong and these guys were right. It's actually, there's another point of view that is somewhere in between those. I think
I mean, if there's a new view there, then that's it's exciting, right?
I've
And this,
been
I mean,
excited by it. I wasn't expecting to think about philosophy, but
I think there's a very vexed question about the way we use concepts like abstract and physical, in the distinction between, typically we think of numbers and mathematics as abstract, and we think of physics as physical. I mean, that's maybe the definition of physical, right? It's what physics describes. And then we have this issue, right, of like, well, how come there's so much mathematics abstract in physics, physical? It's almost like something is. I mean, there's no reasonable explanation of why mathematics should be so useful in physics if they are these utterly independent realms. And that seems to be pointing us towards the idea that maybe we should reconsider this distinction between abstract and physical.
well, I think also the fact that mathematics has proved to be so useful in physics is a consequence of where we're looking in physics. There's plenty of things we could think about in physics where the mathematics we have so far is not particularly useful. We've just been, it's kind of an effect of
Oh, yeah, the mathematics that we have. Yeah, yeah, yeah.
right. The
But I
mathematics we
mean,
have has led us to the physics we have. There's
yeah,
plenty of
yeah.
physics we can even imagine doing, whether it's about turbulent fluids or whatever else, but we just haven't been able to get anywhere with the mathematics we have. And so the towers we build in physics, where we build engineering, for example, on top of what we know in physics, those
Yeah.
towers haven't been built. So we just,
But you'd guess
those
that
are
there is a mathematics of that stuff. It's just that for whatever reason we haven't got there yet. I mean, would there be a physics that just doesn't even potentially have any mathematics? I mean, that
well, what do you
seems.
mean by mathematics? I mean, the point is
Yeah,
that
well, good
that
question. Good
often
question.
often what people in fact in practice mean, from the time of, when Newton started applying mathematics to physics and it worked, what worked for him was he derived a formula for the motion of, a planet around the sun or something. And that meant a formula meant that you could do the thing that is the vaunted feature of physics, which is, you can make predictions. You can
Mm.
make falsifiable predictions, et cetera, et cetera, et cetera. You can jump ahead. Instead of following the planet every orbit, you can jump ahead and say, I know the answer, it's just this formula. So insofar as people say, you can apply mathematics to physics, and it's mathematics where the mathematics kind of comes to closure and just delivers a formula to you, that is not at all obvious that that will work in all of physics. In fact, I think it doesn't. I mean, this is the
Mm.
idea of computational irreducibility
Right.
denies the possibility of that kind of mathematical success.
Right. So that's thinking about mathematics in terms of calculation. I
Right.
guess I was thinking about it in terms of not calculation, like getting an answer, but structures, the kind of structures that we find in physics,
Right. Well,
I
then the
guess,
question
are
is,
mathematical.
right, are there, well, they're only mathematical insofar as they are abstract in some sense. I think, for example, our models of physics involving, hypergraph rewriting and so on, we're trying to build the mathematics around them. In fact, we have a whole effort. There's geometry from Euclid on. We're trying to build an infrageometry, which kind of starts from these discrete objects and so on. We have to build a whole new mathematics. It's hard work. But the mathematics that, and some aspects of it, will be unbuildable in the sense that we won't be able to say, in there are places where if we push in the wrong direction, we'll end up with computational irreducibility, with undecidability, and so on all over the place. It's only if we push in the right direction that we'll be able to kind of get a long way and be able to make kind of narrative statements, mathematical narrative statements that are decently simple. And I think
Yeah,
that,
yeah,
this question, I
interesting.
mean, it comes back to this question of, are there simple laws of nature? Are there laws of nature that we could ever understand? You know, is there? It is not. I mean, one thing that's interesting in the whole Rulliad picture is we can understand the concept of the Rulliad, and there are certain, we can pick slices of the Rulliad where the rules that are being applied are simple enough that we could kind of narratively fit them in our minds. We can also imagine slices of the Rulliad which are not like that, which will be, in some sense, if we were to sort of project the Rulliad in that direction, it would be a very incomprehensible version of how the universe works. It would not be. And so, I think that this question of why, I mean, in the idea that, God had a plan, and it was a sort of almost human level plan that was narratively statable, that puffed out into our whole universe, then we can discover that plan. And that's, then we have an explanation for why that plan is simple. But, as I say, my explanation for why the perceived plan is simple is because that's the only kind of plan that's the slice of reality. That's sort of the slice of things that is the slice that we are taking, so to speak.
Yeah, that kind of
So
self-locating explanation sounds more satisfying to me. The sort of God's plan explanation sounds very well. That was lucky, wasn't it? Lucky that God just happened to be roughly as simple as we are, or or whatever.
well, right,
Lucky that his plan was.
God was
Yeah,
aligned enough as a mind, so to speak. God was aligned enough with our mind that we can decode. But I mean, I think that's, I don't know the
yeah.
whole sort of the theological picture, but I mean, my impression is there's a lot of stuff about, man made in the image of God and things like this, which probably relates to this kind of thinking about why should we be able to understand God's plan, so to
Oh, I
speak.
imagine a lot of it is just sort of unstated assumption. But
About.
the simplicity of the plan, or the nature of God. I mean, there's also an awful lot of, the religious questions are sort of a real tangent, but it's a traditional view that God's mind is unknowable. But there still
Right.
seems to be this assumption that we can maybe
That
decode
it's mind-like
aspects of the
in our
plan.
right.
Yeah, yeah,
Even if
yeah,
it's
yeah. Talking of,
unknowable,
yeah,
it's somehow, even
yeah,
saying
yeah,
the mind of God, in a
yeah,
sense,
yeah,
one thing that I view as sort of interesting is there's nature doing all its things, and then there are minds. Minds are a very special aspect of what happens in nature. Minds, for example, have this idea of single threads of experience. There is much in nature that is in some sense mind-like, but in other senses not human mind-like. And I think the very concept that there is a mind of God, I think in some sense is already assuming some sort of some kind of human projected version of what's going on. I mean, I'm
yeah.
curious
I
what
think that's a reasonable explanation, right? I mean, to sort of understand the world, it's natural to project,
right.
but that doesn't make it a good explanation.
Right, but I mean, in philosophical traditions, have there been people who sort of said, when they say the mind of God is unknowable, can there also be the mind of God is so complicated? When they say unknowable, my impression is that's a lot about, I don't, what do they mean by unknowable? I mean, too
Oh,
complicated to
yeah,
understand.
good question. I mean, could be wrong about this, but I think at some point it was a heresy to think that you could, you know,
I see.
know the mind of God. That was a definite beyond the pale with fiery consequences. Um, I think my history is not great. I think Spinoza had the idea that God has infinite attributes. Whatever that means,
I
I've
think
never been able to
didn't
understand.
Moses Maimonides, didn't he have a whole thing about God is something about infinite attributes of God, and that God, I think he may have been, but I
Possibly,
know I know
yes. Yeah.
I know Spinoza got into that whole. I mean, Spinoza
Yeah.
has this
Yeah.
nice thing about you know the universe is the thoughts of God actualized, so to speak, which is kind of a nice vision of how that might work. Well, it's some all right. We better wrap up here. But this is we
We're
could
gonna
go
have to
down
at some
an
point, and
infinite
maybe
number of rabbit
now is as
holes.
good as. Yeah, yeah.
Yeah,
There
yeah,
are so many rabbit holes. It's been such an interesting conversation. Thank you for
yeah,
that.
yeah. Thank you, and thanks to our viewers here with lots of questions that
Yeah,
we haven't
thanks for
answered.
listening, everyone, and well, hopefully we can do it again sometime. It's been fun.
Sounds good. All right, bye everybody.